We talk all the time about how powerful AI is, right? But what about its biggest weakness? Today, we are cracking the code on one of the most surprising challenges in all of artificial intelligence, its shockingly short memory.
So, let me ask you this. What if the smartest AI in the world had the memory of a goldfish? It sounds crazy, I know, but in a lot of ways, it's actually true. And if you can understand this one single limitation, you hold the key to unlocking the entire future of truly intelligent AI.
To get why, you just need a simple analogy. Think of a large language model like a superpowered CPU. I mean, it's got just massive processing power. But its context window, which is its working memory, that's like RAM. It's incredibly fast, but it is also incredibly limited. And here's the kicker. Anything that doesn't fit in that RAM right now, well, for the AI, it literally just ceases to exist. Poof, gone.
And look, this isn't some minor technical issue. The folks at Cognition AI, the team that built Devin, the AI software engineer, they put it really bluntly. They said context engineering is effectively the #1 job of engineers building AI agents. So managing this tiny memory, it's not just part of the job, it is the job.
So if that's the #1 job, how in the world do you do it? Well, the solution is a whole discipline called context engineering. You can think of it as the art and science of feeding an AI's tiny working memory with precisely the right info at exactly the right moment. It's about becoming a master curator for the AI's mind.
So how do engineers pull this off? Well, they've developed a toolkit, really, of 4 master strategies to get around this whole goldfish memory problem. Let's open it up and take a look.
First up, we've got the most intuitive strategy of them all: writing context.
This is literally just like you or me taking notes. You know, when you're on a big project, you can't possibly hold every single detail in your head at once, so you write stuff down. For an AI, this means saving important information outside of its immediate memory, so it can be brought back up later when it's actually needed.
And these AI notes basically come in 2 flavors. You've got scratch pads, which are for temporary thoughts on a single task, kind of like a to-do list you can check off. And then you have long-term memories, which is where it saves key info across different conversations. This is what allows it to actually learn and remember things, like who you are and what you've worked on together before.
Okay, but just writing everything down creates a whole new mess, right? How do you find the right note at the right time? And that brings us to our second strategy: selecting context.
So if writing is about saving information, selecting is all about retrieving it intelligently. Think about it. A researcher doesn't read the entire library to find one fact. They do targeted searches. This strategy is all about pulling only the most relevant information back into the AI's limited memory. It's about finding that crucial signal and cutting out all the noise.
And why is this so critical? I mean, this chart says it all. When you give an AI agent a small, manageable set of tools, let's say under 30, its performance is great. It's high. But as you start dumping more tools and more information into its working memory, its performance just falls off a cliff. Give it over 100 tools, and it often just fails completely. It gets distracted, confused. So selecting the right tool for the job isn't just helpful, it's absolutely non-negotiable.
Okay, so we can save information, and we can select the right bits and pieces. But what happens when even the right pieces are just too big to fit? Well, that leads us right to strategy number 3, compressing context.
This one is all about pure efficiency. It's like summarizing a book. You don't need every single word to remember the plot, right? By compressing conversations and data, the AI holds on to the most important ideas while freeing up that precious space in its working memory. It prevents what engineers call token bloat.
And in practice, you see this in a couple of ways. An AI might automatically summarize a long chat history just to remember the key takeaways. Or it might use trimming to only keep the most recent messages, assuming those are the most relevant. It's like it's constantly tidying up its own memory to stay focused on the task at hand.
But what about tasks that are just way too big, way too complex for any single AI, no matter how well its memory is managed? This is where our fourth, and I think most advanced strategy comes into play: isolating context.
This is where things get really, really clever. Instead of trying to cram everything into one AI's brain, you use teamwork. You can split a massive, complex job among a team of specialist AI agents. Each one of those agents gets its own dedicated workspace, its own isolated context window, so it can just focus on one piece of the puzzle without getting distracted by everyone else.
So you see, these 4 strategies, writing, selecting, compressing, and isolating, they're not just a handful of individual tricks.
They are the fundamental building blocks that engineers use to build some of the most sophisticated and advanced AI systems out there.
And here's where you really see the payoff. These strategies combine to create these powerful design patterns. You combine writing and selecting, and boom, you get memory management, an AI that actually has a long-term memory. Use selecting by itself, and you can build a routing system that works like a smart receptionist, sending tasks to the right specialist. And isolating? That's the foundation for true multi-agent collaboration, a whole team of AIs working together.
Let me give you a powerful example called prompt chaining. Picture an assembly line. First, one agent executes step 1 of a problem. Then, a totally separate validator agent checks its work. It asks, is this correct? Only if the work is valid does it get passed to the next agent for step 2. This step-by-step process with built-in quality control creates these incredibly reliable and error-resistant workflows, and it's all made possible by carefully managing and isolating context.
You know, in the end, it really all comes back to this elegant summary from the AI expert Andrej Karpathy. He said, context engineering is the delicate art and science of filling the context window with just the right info. The key isn't having the most information, it's about having the right information at the right time.
And that leads us to the biggest insight of all. If the language model is the CPU and the context window is the RAM, then context engineering, that's the operating system. It is the foundational software layer that manages all the memory and all the resources, enabling every other application to even run in the first place.
So that leaves us with one final, and I think pretty fascinating question. If what we are building right now is the fundamental operating system for this new kind of intelligence, what are the killer apps that we are going to build to run on top of it?